Hello, and welcome to Module 12.3, Using Data. Our objective for today is that I can identify potential bias in sampling methods and questions, and I can identify potential bias in statistics and representations of data. Our vocab fest is continuing today with some new words. So our first word is population. This is all members of a group of interest about which data will be collected. And our second one is related to it. It's a sample. It is a subset of the population used to practically collect data. So let's talk about this in a little more detail, these two specifically. Population, this could be all of HMS, right? All 900 students here at HMS. The sample could be, we could use a sample of maybe like one from each class, for example, right? A sample is supposed to be a smaller segment of the larger population. Okay, a small sample of the larger population that we can practically collect data on and then extrapolate or use that data and those trends to make predictions about what the larger population is going to do. So when you are doing surveys about, this is most common in like advertising and market research for companies, but also political research and political messaging. So they are going to find a poll, they're going to sample a small amount of people, and then they are going to use that to make predictions about what the entire state of Illinois or the entire United States voting population is going to do. So by using representative samples, you're able to make predictions about what the larger group does with a certain degree of certainty. Now, let's take a look at sampling methods. These are three different ways in which we can choose the samples we use. Random selection is selecting by chance. Everyone has an equal chance if it will write nicely. So everyone has an equal chance to be selected. So you put all of the names in the hat and you pick one out. Everybody has an even chance of getting selected from that method. Completely random. So this is great for manufacturing because you don't necessarily want a pattern because patterns can be deceiving, right? But is this necessarily good with trying to find information about people in a school? Maybe not as well, because you might end up pulling a whole bunch of kids that are in the advanced class by random chance. Or you could end up pulling all sixth graders and not have any seventh or eighth grade representation because everybody is selected at a random and it's equal chance for everybody. All right. So then we have a method called systematic. And this is where you select a number at random and then survey every nth person. So this could be, I'm going to survey every 10th person to walk into the lunchroom, right? Or it could be in manufacturing, we are going to test every 100th product to come off of the assembly line. And that's going to give you, if you're doing that systematically over and over and over again, you're going to get a consistent sample and you're going to be able to evaluate, is your production working correctly? In the social sciences, is your data, what data are you trying to collect? What patterns are you looking for in the population? Our third sampling method is stratified. And this is where you split the population into separate groups and then survey at random within them. So this would be like if we were trying to sample Huntley Middle School, we're going to split by grade first. And then do random. So we're going to split it into a smaller group and then do a random sampling. So if we split by grade, so now instead of a 1 in 900 chance of getting selected, you have a 1 in 300 chance of getting selected. And you're going to get representation from sixth grade, seventh grade, and eighth grade. In the larger world, political world, you're going to do stratified because you are going to start looking at, when you're looking at a presidential election, for example, you're going to have data based on counties or by congressional districts because you're trying to target your advertising to specific regions. So you're going to break it down by what are my regions that I need to look at, and then I'm going to do a sampling within that region to find what information I need about my candidate or about their messaging or what the voters or the constituents want. So stratified is a really good example, especially if you're looking to get a large spectrum of people, but you want to know what each of these different pockets are involved with or caring about. So this brings us to our next part, which is bias. Bias in a statistical sense is an error that results in a misrepresentation of a population. So if I'm trying to survey and find out what people like at Huntley Middle School, but I only am sampling from my advanced classes, I am biasing the sample because not every class is advanced. If I'm only selecting sixth grade classes, that's biasing the sample against the rest of the population. You are not seeing what everybody across the building is doing. And so you can see errors creep in. And when you have these errors, then it leads you to drawing wrong conclusions or making wrong decisions because your data was not good enough. Lastly, we have a statistic, and this is a measure that describes a characteristic of a sample. So let's take a look at example 1, sample bias. Before the 2010 elections, for members of the U.S. House of Representatives, pollsters called American households on their landline phones to see how they plan to vote. Is this a good sample? And if not, what kind of sample bias might have affected this poll? So the first thing you may say, calling people at random to see how they plan to vote is a good thing, but here's the key right there, on their landline phones. I don't know about you, but not a lot of people have landlines anymore. Specifically, so this would be no, not a good sample. And the reason being is not a lot of younger people have landlines. So a lot of younger people, and I'm one of them, don't have landlines. And what is this going to result in? Well, typically, the way our country has been in recent years, the older population has typically leaned more Republican, more conservative than the younger population has. This is on average, so not any specific individuals, but in a general trend. So by only sampling people with landlines, you are sampling a very specific demographic of the population as a whole. And you're not getting a full picture of all of those younger people that do not have a landline. They only have cell phones. All right, let's look at letter B. We have a high school principal that wants to determine how much screen time per day his school students have. Good idea so far. For the poll, the principal talks to students who are staying after school for track practice. Is this a good sample? And if not, what kind of bias might affect the poll? Well, this is definitely not a good sample. And the reason it's not a good sample is going to be you only have one group. You have a group that are athletes. So they are after school, they are at a practice. So they may not necessarily be representative of the students as a whole. You have a lot of people that are not active in sports or other athletics that maybe they would have more screen time than an athlete would because an athlete is spending time at practice that others may be spending time on screens. So this is not a good sample because it is not really representative of your entirety of your school because of the fact that it's just the after school track practice that you're looking at. All right. The next two are you tries. I want you to do those on your own and then check your work against mine. So, letter C, Shia wants to determine the age of the average internet user. He posts a poll to his friends on a social media site asking their age. Is this a good sample and what kind of bias might happen? No, it's not a good sample, and it's only his friends that are being sampled. So, likely his friends are of a similar age demographic, and it's only on one social media site. So if you posted something just to your friends on Instagram, does that really represent all internet users in terms of finding their age? Right? Specific apps have specific age ranges that are their typical demographic. You know, Snapchat, Instagram, TikTok, much younger demographics. Facebook, usually going to be an older demographic that has that. So, depending on your social media platform, you are going to get a bias in your sample because of the typical users of that platform. Now, if this was being broadcast on all social media networks and platforms, then perhaps it's a little better of a sample, but it's still limiting yourself to only one person's friends. All right, letter D. We have Micah. Micah wants to know what outdoor activities people in the community enjoy on the weekends. He interviews every fifth person at a local bike trail on Saturday. Is this a good sample? And if not, what kind of sample bias might affect it? So this would be a stratified sample. It's you're going to one specific place and it is systematic. You are doing every fifth person. So that sampling method is good. Are we going to see a bias? So not a good sample. And why not? Well, we're asking about what outdoor activities people enjoy. But we're going to a local bike trail on a Saturday. What is the bias that we're going to have? They're already doing an outdoor activity on the weekend. So there may be a lot of people that go swimming or, playing basketball or pickleball or whatever sport they might be doing. But you're at a bike trail, so the majority of people that you see are most likely going to say that they enjoy biking on a weekend because that is what they are doing. They're on the weekend and they are out there. All right. Example two, we're going to look at question bias. Does each question potentially bias the results? And whose interests might be served by the bias? That's an important, sub thought to have on these is what is the purpose of the bias? So we have a survey organization wants to see what percent of New York City citizens support a ban on soft drinks. The question is posed, do you support a ban on soft drinks which contribute to heart disease and tooth decay? So is this a question that's going to potentially bias the results? Yes, it will. And the reason why is this part right here, which contribute to the heart disease and tooth decay. So what is going to serve this bias, right? What is the reason? This is going to bias people, or it's going to be, supporting of people who are for the ban on soft drinks. right? By including information saying it's contributing to heart disease and tooth decay, that might lead people to supporting a ban that might not otherwise have supported it. All right. Our next question, letter B. One of your friends wants to determine whether people in your class prefer to watch movies or television. She asks, do you prefer to watch movies or television? Is there any bias in here? I don't see any. It's a very, non-opinionated, non-emotional. It is a straightforward question. So there's no bias. Letter C. A new television program, The Morning Zone, has been airing, and a group wants to determine how people feel about it so far. They ask, do you love, like, or have no opinion on The Morning Zone? Does this question have potential bias? Yes. The reason why? There are no negative options. And who might support this? Morning Zone creators. They could potentially be doing that. They want to be able to say that they have this positive response. And so the way you can do a positive response, you could make sure there's no negative responses. All right. We have letter D. A health organization wants to collect data about vaccination rates for children in the area. They ask, should concerned parents vaccinate their children? Does this bias our sample? Yes. Because it's going to be, concerned parents, right? You're saying if you say no to vaccinating, well, then are you a concerned parent, right? So the question is kind of putting some bias in of judging people who may answer one way or the other. Who would be benefited or what interests might be benefited by this bias? This would be people who are pro vaccine, right? By biasing it to say that if you don't get your child vaccinated, you are not a concerned parent. That's the implication in this question. That would be certainly a bias in favor of vaccinating. All right, data summaries, example 3. So we're going to take a look at a summary and we are going to evaluate, is the representation accurate? So a teacher wants to tell students how the average student did on an exam. So he looks at the scores in his gradebook. 2 students scored a 0 because they stopped showing up for class in the last month and did not take the exam. He uses the mean, 71, as the measure of center. Does the mean accurately represent this data? So if we just put that in, 71 in the sequence would be right there. Okay, so does that represent the data? No, it does not. So it doesn't represent the data because it's not representing those that actually took the test, right? The mean is below everybody who actually took the test. And this is because you have these 2 outliers, the 2 zeros that are pulling your grade down, and you are outlying and it is outweighing everything else. So now the mean ends up 10 points below what the actual average of all of this data would be, all of the other scores. So what would be a much better method? I would say probably median would be your most appropriate method here, because that would be this value there instead. All right, let's look at letter B. Karen writes down the numbers of books she has read for each of her classes so far. 5, 6, 4, 5, 5, 6, 5, 4, 5. Using the mean, 5, she says that she reads around 5 books on average for an English course. Does the mean accurately represent the data for this situation? I would say yes, right? Because by saying a mean, you're saying your middle value is 5. Well, you have 1, 2 above 5, you have 2 below 5, and then you have 4 that are 5. I would say that's a very fair representation of this data. You try, letter C, you're going to do this on your own and then check your work with mine. So a book publisher is going to release a paperback edition of one of its books and wants to include positive press for the marketing. The publisher looks at online review scores, measuring 1 to 5, and decides to use the mode for the measurement, or for the claim that the book, quote, received an average of 4 stars in its reviews. Does the mode accurately represent the data? I would say no. There are more less than 4 stars. So there's more people. So we've got 8 people are below 4 stars, 5 are at 4 stars, and 2 are above. So more than half of your data is below the claim that you're making that it received an average of 4 stars. So I would say it's not a great claim, especially given the spread of data that you see there. All right, let's take a look at letter or example 4, data representation. So representing data is a very fine process. You need to make sure you do it without bias. How can you make a bias in a graph? Well, we're going to see some examples of bias in graphs. So first off, we have letter A here. A group compares 2 soccer players who play the same position for different teams. They make a graph of the data of goals scored throughout the season for each player. Do the graphs misrepresent the data, and whose interest might be served by that representation? So if we look at our 2 players, we see that they have both scored 30 goals. Whose graph looks like they've scored more goals? Player number 1. So we're going to say this, is there bias in this graph, or is there a misrepresentation? We're going to say yes. And you've got same values. But player A, or player 1 rather, not player A, player 1, looks like more, right? And so this is an example of manipulating your y-axis. Right? Manipulating the y-axis, and then whose interests might be served? Maybe player 1's agent or sponsor. They want to show their player as being better, so they're going to present the data in a way that it looks like, even though they're the same values, their player is going to look like they have a greater value. All right, let's look at letter B. 2 graphs below represent the same data. Which graph provides the best representation of the data? And well, we've got Arkansas football wins. And so if we zoom in on one, we can see that trend line. And it looks like, hey, you know what? Arkansas looks pretty consistent from 2000 to 2016. But then we look at a graph with a different y-axis and we can see, oh, yeah, maybe they're not as consistent as the graph looks. So which one best represents how Arkansas actually did from 2000 to 2016? It's going to be this one right here. And again, this is an example of manipulating the y-axis. Right? By manipulating, by changing the scale of the y-axis, we can, by making it really big and going up to 100 wins, which is ridiculous because the most games a college football team is going to play is maybe 15, but it's definitely closer to the 13 range depending on the conference. But going up to 100, all you're doing is compressing your data smaller and smaller and making it look like there's less variation than there actually is. So all that empty space on your graph is not giving you a true representation of the data. So you need to set your scales appropriately to see the data. So letter C, what do we got? We got two graphs below representing the same data. Which graph presents the best representation of the data? So both are showing us appellate judgeships, so judges to the appellate courts confirmed during the first congressional term of the last 6 presidents of the United States. And this is up through, actually, this is not quite the last 6 because it ends after Donald Trump's first term in office. So it does not have Joe Biden on here, and it does not have, obviously, President Trump's second term on here, as his second term is, we're not through our first congressional cycle yet anyways. So as we look at these two pieces of data, right, on the left, we've got the gavels with lengths on them showing how long they were, and on the right, we have these bar graphs. On the left, it makes it look like Donald Trump had way, way, way more judges confirmed than anybody else, and that it looks like Barack Obama had very few judges because it's just got a little teeny tiny handle on the gavel. So which is the better graphic? It's going to be the one on the right. Now, the one on the left is more engaging because it is showing, a picture instead of just a bar graph. But what we're doing is, this is called omitting the baseline. So by omitting the baseline, by skipping over those 0 to like 10, you're skipping the fact that everybody has the same starting points, right? The one on the left makes it look like Donald Trump had significantly more. That looks like it's double or triple of what Barack Obama did. But in reality, it's only 9 more judgeships, right? So by not including the origin, by not taking it to 0, we are misrepresenting the way the data looks, and it can be used to say Donald Trump had this outsized impact on the appellate court that he didn't really have, right? He's at 24 and Ronald Reagan's at 19. So a difference of 5 judgeships is looking like it's at least doubled on the Donald Trump graphic on the left. Okay, so the way in which we represent data is significant. So the next page is all you try problems. I want you to work through them on your own and then check your work with mine. All right, letter D. We have a recent measure was passed by a student council to improve attendance and will take effect in the second semester. A graph shown is released to indicate how the measure has affected attendance. Does the graph misleadingly represent the data? I would say absolutely yes. It makes it look like does it look like there's a significant change there? Yeah, it looks significant. You have a huge difference between these two bar graphs until you look at the scales and you realize they were going from 0.05 to 0.06. And we're starting at 90%. So that bar graph should be quite a bit bigger to show the other 90% of the data. And the difference we have is just this 0.06%. So let's just say, for example, Huntley Middle School here, we have approximately 900 people. And I want to know what is a 0.01% of the difference. So that would be less than 1 person in our building in terms of attendance. So you can see how this is very misleading. So it makes it looks, pen does not like me today. Makes the gap look significant. So so this is omitting the baseline. That's the mistake that's happening here. But whose interest would serve a graph like this? Well, if you're trying to make the argument that your data, that your solution is working, you're going to want to show it that it's working significantly. And so this shows, hey, look at these two graphs. This looks like a big spread of data. My idea was great, when really it didn't change things that much. Letter E. So we've got two graphs that are both representing the price of Tesla stock in recent months. Does either graph misleadingly represent the data? And the answer would be yes. Both graphs misrepresent data. So we are manipulating the x-axis this time to show changes. And I pulled two very specific intervals, right? I pulled the 6-month data, so going back to mid-October through mid-February or mid-April, and I pulled from the year to date, so January 1st to the present. You can see they're representing the same data, but it looks a lot different, right? The one on the right is red, meaning it's losing money over time. The one on the left is green, meaning we're higher than we were 6 months ago. So the time frame, the intervals that you choose can manipulate what you see in terms of the price. I was looking at some stocks recently, and I see they have an interval, and their 52-day range is from $2 to $800. And I look at the graph of it, and it looks like a straight line coming down at some point. It makes me wonder what happened at that point, right? So you should look at various representations. If you're just seeing a 3-day trend or a 5-day trend of a stock, you might want to look at the broader, like, what's the wider trend? What's happening in more time to see what's going on with this stock? So by manipulating the x-axis, we can show, I can be like, hey, Tesla's doing okay, it's green. Or I can say Tesla's doing bad, it's red. I can cherry pick some days there where after the tariffs were announced, Tesla's stock went down $20 and $30 a share a day. And I can use that crater as a representation of the stock. But is it accurately reflecting the stock's performance over time? Not necessarily. Letter F, we have two graphs representing the same data. Which graph provides the best representation of the data? So we have COVID-19 cases in the United States. One is from Johns Hopkins University. This is a medical center, and one is from Fox News. COVID gave us so many misleading graphs trying to sway you to the opinion of whoever is the one putting them out. But one thing that you want to look at, and this is something that middle schoolers tend to do on their graphs, they try to pick scales that, don't necessarily make sense. They want to pick scales that show their data easily so they can just graph on lines on the grid. But that's not the thing you should do. So what you need to do, you need to have consistent scales. Your scale needs to go up by the same amount every single time. So we've got as you're looking at the data, you've got differences in the date ranges, right? So we have a 3/6 data over here that's not on the Fox News one. We go to the 10 to the 15 to the 20th to the 24th. So other than that, you've got one data mark that's not included there. But you see, we're going up by 5, then 15, then 15, then 15, then 15. Well, why do we have that big jump there? Because it's making it, it's less steep of an increase if we change our scale. On the Johns Hopkins one, we see every single line we're going up by 10,000 cases. So this is going to be manipulating y-axis scale, right? And the Johns Hopkins one is going to be the better representation because it is keeping it consistent um, based on the data that they're given, right? The scale is consistent, and you can even see this is using the Johns Hopkins tracker data. So they just chose to make a graphic that looks a little differently so that they can argue their political points. Something that you should be aware of as you read any news source. Last one, we've got what is misleading about this graphic. We've got the KFC's crispy chicken twister. We've got calories listed at 650, and we're comparing it with pizza, like probably Sparrow, maybe. We got McDonald's, we got KFC, Taco Bell, Burger King, and Wendy's. And what are we doing? What is the misleading portion? We are omitting the baseline, right? Because each one of these bars should go way this way. And so now your data doesn't quite look all that different when you realize that you're ignoring the fact that there's 600 calories below this. And that's even, this what I drew in there is even more so because that whole width of the graph is 120 calories. So figure you've got six more of this entire graph basically to the left of it, showing you all of the rest of the calories. So it's misleading in terms of saying maybe KFC isn't quite as bad as some of the others. You're missing out on some of these differences. All right, that is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.